Okay, this is the video for week 3 for examples, and you'll use this to be able to do your homework. So your homework will be similar. So this is something that I have used in my stats classes in person. So what I do is I give everybody a Chips Ahoy chocolate chip cookie, and before they eat the cookie, they have to count the number of chocolate chips in the cookie. And I try to make it so that like I tell them to make sure it's like a whole chip and not just like a little speck, but you know, obviously you get a wide range of numbers depending on what people define as a chip being there or not. So anyway, so this was for a particular class. So this was the number of chips in the cookies. There was 29 in this class. So that's our numbers that we're going to use for these examples. So the first thing you want to do when you're given a data set here is determine if it's a sample or population, because when you do your homework and stuff, it'll ask you to use proper notation. And so that means, you know, you need to know if you need to use X bar or mu or S or sigma and all that. So is this a sample or population? This would be a sample. We did not use a whole pack of cookies. And if the whole pack was used, you could argue that it was a population because we used the entire pack. But you could still also argue that it is a sample because, you know, the packs are made, like they make a whole big batch and then they put them in the packs or whatever. So the population, you could say, is actually the entire batch and then it's separated out into packs. So this one, you could argue it either way. If you used a whole pack for your homework and stuff like that, it'll be clear as to which one you're supposed to use. Because it'll say all, entire, or whole, or one of those words to indicate population. So it'll be a little more clear. You won't have to, you know, argue it one way or the other. So anyways, so for this particular one, we didn't use a whole pack. So regardless, this is a sample. So we're going to use sample notation. Okay, so you want to find the following and then label using your proper notation. And you can use the calculator if possible. You don't have to use a formula unless it's something that requires a formula. So we're going to find all these things here for this data set. So I'm going to start just going through here and labeling the ones that need notation, and then I'll come back and do the answers. So for the mean, it does have a symbol, so it's a sample. So this is going to be X bar. The median does not have a symbol. The mode does not have a symbol. Mid-range, there's nothing. Range, there's nothing. Standard deviation, it has a symbol, it's and a sample, it's S. And the variance, same thing, it has a symbol, it is S squared. So, so I'm just going to go ahead and label those so I know I don't forget to do that. Okay, so what we're going to do is I'm going to show you how to do these on the calculator, and then I'm also going to show you how to do it on Desmos. If you don't have a calculator, you can use Desmos. Some of them your calculator will not do. So the calculator will give you the mean, the median. It won't give you the mode. You have to use the formula for mid-range, range formula. It'll give you the standard deviation and you can square it for the variance. So the calculator will give you some of them it won't give you. But we'll just start and I'll show you the calculator first. So I'm gonna go ahead and do everything on the calculator and then show you how to do Desmos, okay? So if you're using the calculator, what you wanna do, my calculator's on my computer, is you go to Stat and Edit, and then you want to type in those numbers. So 27, hit enter, 20, hit enter. So I've already done that just to save a little bit of time. So here's all my number of chips in a cookie. That's all my numbers there. There should be 29, and there are. And so once you have that typed in, you can go to second and mode to get out of there. So you type your list in first. Then I want to know, we're starting with the mean, so I want to know the mean. So I'm going to go to Stat, over to Calc, and I'm going to pick one var stats, which is the first one. And then I can just hit enter, and it should just run and give me, my first thing it gives me is X bar, which is what I want first anyways, is the mean. And so I'm going to round these to 2 decimals. I didn't say, but we'll just round them to 2. So my X bar is 19.69. That's the average number of chips in the cookie. So X bar is 19.69. It also gives me the sum of X squared, which you need if you use formulas, but we're not going to use formulas if we don't have to. SX is my standard deviation, and sigma x is the standard deviation. So it gives you two different standard deviations, and the reason is the calculator doesn't know if you have a sample or a population, so you have to know. So that's why it's important to always know which one you're dealing with, because when you're writing it down, you're going to look at SX if it's a sample, and you'll look at sigma x if it's a population. And so for this particular one, we already said it was a sample, so we're going to look at SX. And remember, and I'll go ahead and do that one, 5.298, if I round to 2 decimals, the 8 bumps up the 9, which bumps up the 2. So just so you know, when you do it, calculator notation says SX. What you want to write down is just the S. So that's proper notation. Calculator notation gives you SX, but you just need to know which one you're looking at. So so far I've filled in the mean is 19.69. My standard deviation is 5.3. And then it's got N is 29, which is how many numbers I had typed in there. And then if you scroll down, it gives you your 5-number summary. So it gives you your minimum, your Q1, your median, your Q3, and your maximum. So when you need to do your range or your mid-range, you have to use your maximum and your minimum. So you could look through and find those yourself, or the calculator will at least give you the max and min so that you can plug those in when you use those formulas. So the calculator will give you the median. I think I said that to begin with. I hope I said it would and not it wouldn't. The calculator does give you your median. There is no notation, so the median is 19. The calculator will not give you the mode. I'll come back to that in just a second. The mid-range is you take your maximum plus your minimum and divide it by 2. So it does give me my maximum, which is 33. And again, like I said, you could look through here and find that, but it does tell me that. Plus my minimum of 12 divided by 2, and there's no notation for this, so that is 22.5. For my range, it doesn't give it to me, but it gives me my max and my min, and that the range is the difference. So I'm going to do my 33 minus 12, which is 21. And then for S squared, it doesn't give me the S squared. I have to square it. And when you do this on the calculator, instead of typing in 5.3 squared, that introduces a little bit of a rounding error. So usually what I do is, and if you can also go pull the SX and it'll store that and stuff, and you can square it, but usually it's quicker for me because I can never find that. I just type in 5, oops, if I can hit the button, 5 point, and then I type out that decimal. 298, 944, 964, and square it. Just so that it doesn't give me such a rounding error. So if we round that one to 2 decimals, we should get 28.08. And that's my variance. If you had done 5.3 squared, I don't think this one matters much. It gives you 28.09. So this one doesn't change it too much, but it does introduce more of an error when you use a rounded decimal. So just make note of that. And so the last one we have to find is the mode. Now for your mode, calculator won't help you other than it will sort your list for you. Whoops. So you can go through and look at your table and find the mode. So like you can count how many times each number occurs. I see 17 4 times when I look at it, so it's probably 17. But it is easier, it is sometimes easy if you go into stat, and then you can do sort ascending or sort descending. It doesn't really matter which one you pick as long as you get it sorted. So I'm going to sort ascending, and you have to tell it what to sort. So I want it to sort list 1, so I hit second 1 to tell it to sort list 1, and it'll say done. And then when I go back into stat and edit, it's sorted. So then if it is sorted, you can count. So 12 occurs twice, 14's 3 times, 15's 2 times, 17's there 4 times. And so you can go down and count a little bit quicker than looking at the table in this case. Oops. So 17 would be my mode. So the calculator doesn't tell you the mode, but it will help you with the sorting if you want to sort and count instead of looking up here. 29 numbers isn't bad to go look for a mode, but it does help, I think, when you have several numbers, it helps to sort them on the calculator. Okay, so there's all my answers, and that's how you find it on the calculator using the Stat Calc 1var Stats or the formulas that you have, or you square the standard deviation. Now, if you don't have a calculator or you just want to know how to use Desmos, I'm going to show you how to do that next. If you don't want to know how to do it on Desmos, you could fast forward a couple minutes here so that you can just skip that part. So for Desmos, if you go to Desmos, to type in a list, I've already done that again to save time, so I called it C for cookie, is equal to a bracket, and then you just type in your numbers with a comma, okay? And then if you go down and click on the little keyboard and go over to functions and up to stats, you have total, length, mean, median, minimum, maximum, quartiles, standard deviation. This is for a sample. Standard deviation P is for a population, variance, and some other stuff here that we've not got to. So if you want to find the mean, which is the first thing we wanted to find, is I want to find the mean of C, and it tells me it's 19.689, so on, which is what I got when I did it on the calculator. So let me go back. See, stat, calc, oops, one too far. So there you can see that this one gives you a couple more extra decimals, but the decimals that the calculator gives matches all of them that Desmos gives, and so that's always a good sign that they match. So that's my mean. And then we want the median. So again, if you go to Desmos, if you go back to functions, it'll give you the median. You can click median. Oh, actually, I guess oh, there it is. Lost it. And you can hit C, and it says it's 19, which is what we got on the calculator. It'll actually also give you the 5-number summary if you want them all. So if you go to stats or function and then click stats and do C, that gives you the 5-number summary. Your minimum, your Q1, your median, your Q3, and your maximum. And that matches over here what the calculator had as well. So if we scroll down, they match. So again, it's always nice to know everything matches so you know it's typed in right and you're doing it correctly. So Desmos doesn't give you the range, but it will give you the maximum and the minimum. And the mid-range, same thing, like we did it on the calculator. For standard deviation, you go to functions and you pick standard deviation for a sample. This one's for a sample, this one's for a population. We're doing a sample of C. And again, it's the same, 5.298, 5.3 is what we had. And then Desmos has the variance where you don't have to square this. You can click VAR and do of C, and it still gives me the same thing, 28.0788, yada, yada, yada. So 28.08, which is what we said. Desmos will do everything the calculator will do. You just have to know it's under functions and stats and click on the right things. I'm not exactly sure how to sort a list in Desmos. I don't know if it has a sort. I've not used Desmos a whole lot. I don't know if it'll let me. No, see, and it doesn't. I don't know how to get it to spit it back out. It didn't give me an error, but anyways, if somebody knows how to get it to show you what C is, because it says there's a list there, but I'm not exactly sure how to get it to sort and then spit it back out to me. But anyways, it's not too hard to find the mode without sorting, but you can use a calculator, or like I said, it does everything else the calculator does. And I'll try to look into that some more and find that. Okay, so that is it for question 3 there. So now what we want to do is go to number 4, and it says, is 10 chips in a cookie unusual, and show your work for your minimum and maximum usual values. So your minimum and your maximum usual values. Usual values occur within 2 standard deviations of the mean. So Your minimum usual value is x bar minus 2s, and your maximum usual value is x bar plus 2s. Your mean minus 2 times your standard deviation, and your mean plus 2 times your standard deviation. So in our case, we had, I forgot what my numbers were. We had 19.69 was our mean, so 19.69 minus 2 times our standard deviation of 5.3, and then we're going to do it with a plus. So if I do that on the calculator or whatever I'm using, I'm just going to, I've got Desmos pulled up here, so I'll just do that. So 19.69 minus 2 times 5.3, that gives me 9.09. So that gives me my minimum usual value. And my maximum usual value is, I do like Desmos that you can change to a plus, and because you know on a calculator you can't change stuff very easily, so Desmos does allow you to change it. So 30.29 is my max. So that's my minimum usual and my maximum usual. So it says, is 10 chips and a cookie unusual? The answer is no, because 10 falls between these two numbers. If it was outside of these two numbers, then the answer would be yes. So if the question had asked, I think there was 33. Yeah, our maximum was 33. So is 33 chips unusual? You would say yes, because it's outside of this range of numbers. Okay, so number 5, construct a box plot of the data, include your 5-number summary, find the interquartile range, and list possible outliers. So our 5-number summary, which I've already mentioned, I just haven't wrote down, is your minimum, Q1, your median, your Q3, and your maximum. That's my 5-number summary. So I've already done it on both Desmos and the calculator a couple of times, and we've already talked about it. So right there it is. So 12 is my minimum, 15.5 is Q1, 19 is my median, 24 is Q3, and 33 is my maximum. And that was the same, we already said that was the same on the calculator when I scrolled down, so like I said, I've already mentioned that. Okay, so I'm going to draw a box plot, and so we always want to title a graph, so we're going to say number of chips in a cookie is going to be my title. Okay, and I want to go from 33 to 12, and you don't have to draw these perfect when you draw graphs, just like in the last section I said, you know, it is what it is when you're drawing by hand. So there's 10, 15, 20, 25, 30, and 35, roughly. Okay, so I'm going to make my box between Q1 and Q3. So 15.5, which is about right there, I draw a line. Q3 is 24, which is about maybe right there. So there's my box. Okay, and my median is 19, so that's about right there. And if you want, sometimes I'll write the numbers up here just to make it so that I know what they are, because I don't have them all ticked off. So that's my box, and then I'm going to draw whiskers to my minimum and my maximum. So 33 is my maximum, which is about right here. I've got a whisker there, and 12 is my minimum, which is about right here. And I've got a whisker there. Okay, so there is my box plot. And you can put number of chips down here on your scale, because you're supposed to always label things, but the title kind of tells you what that is. But same thing. So number of chips is down here. Just want to make sure we have everything labeled. Okay, so my then it says find my interquartile range and list any possible outliers. So my interquartile range is Q3 minus Q1. So I'm going to do 24 minus 15.5, which is 8.5. Okay, so outliers, not to be confused with the unusual values. So outliers, to find your minimum and your maximum for this, what's called your lower fence and your upper fence, you're going to take your Q1 minus 1.5 times the IQR, and then you do Q3 plus 1.5 times the IQR. So your lower fence and your upper fence, I'm going to say lower fence here is Q1, which is 15.5 minus 1.5 times my IQR of 8.5. And that gives me 2.75. I already did this. Okay, and then for my upper fence, I'm going to do Q3, which is 24, plus 1.5 times my IQR of 8.5, which gives me 36.75. So this is my range of values. As long as my numbers are between these two numbers, then they're not an outlier. If they are outside of these numbers, then you are an outlier. So 2.75 to 36.75. All of my numbers fall between those two numbers, so I would say there's no outliers. Okay, so we just have a couple more here. So calculate the coefficient of variation. So that shows you how much your variability is in your data. So CV is equal to, if you use the formula, it's S divided by X bar times 100 to give you a percentage. So again, if you use 5.3, which is our S, divided by our X bar, 19.69, times 100, it will give you, I forgot what that gives you. I didn't write that down. If you do it with the rounded values, then I can't remember the difference for this one. Times 100, you get 26.9 or 26.92. We'll just round this one to 1. So 26.9% is the coefficient of variation. If you do it without rounded numbers, I'm just going to jump over here to Desmos and do it. So on Desmos, what you can do is you can go to stat, or go to functions, wherever it went to here, functions, and I'm going to do my standard deviation of C divided by my mean of C, and this does it without any times 100. That does it without rounding, and so it's still 26.9. I think it's 9.1 this time, and I said 9.2 last time if we rounded. So, and then on the calculator, you could also do it, you could type in that 5.29 yada yada yada, whatever it was, I forgot what it was now, but all the decimals, and not have a rounding error. But for coefficient of variation, it's not a huge deal. Just keep that in mind. If you use the rounded values, you might be a decimal off from whatever I post if I don't use the rounded values. In this case, if I round to 1 decimal, it's the same. If I took it to 2, one would say 9.1 and one would say 9.2, which is really not that big a deal. So the coefficient of variation is 26.9%. That's how much variability is in the data, so it's not too terrible. Because the smaller this is, the less variability there is. So if you get up really high, then it's a whole lot of variability. But anyways, okay, for the last one here, we want to create a frequency distribution of the data using 5 classes, and then answer your questions, and still label using proper notation. Okay, so to do a frequency distribution, we have to know the class width first. So my class width is my maximum minus my minimum, so my range basically. So I already know my maximum is 33 minus my minimum of 12, divided by, I want to do 5 classes. So if I do that, I get 4.2. And remember, for a frequency distribution, you always round up on the class width. It doesn't matter if it's a whole number or if it doesn't round up truthfully, you always round up. Okay, so my class width is 5. So I'm going to start with my minimum, which is in this case 12. And remember, I don't go 12 and then jump 5 here, I go down. So I do plus 5 going down. So 12 plus 5 is 17. And then plus 5 again is 22. Plus 5 again is 27. Plus 5 again is 32. Okay, so then I fill in the upper class limits by subtracting 1 or going up by 4, whichever way you want to think about it. So I've got 16, 21, 26, 31, and then if I jump here by 4, 32, and 4 is 36. Okay, so remember, class widths go down first. And then I'm going to go through and I'm going to count. So how many numbers are between 12 and 16? And so this is one where the calculator helps you if you sorted it. Like I said, I'm not sure how to get the Desmos to do that, but if I've already sorted it, so I can go through and I can count, okay, between 12 and 16, I have 1, 2, 3, 4, 5, 6, 7, 8, and then I go to 17. So I've got 8 between 12 and 16. So if you've sorted it on the calculator, that helps you with your frequency distribution, or you can go tick them off and tally or whatever. So anyways, I've already counted these, so I'm just going to tell you there's 8, 12, 6, 2, and 1. Okay. So if you go through, I counted it twice, so hopefully I'm right. So what you want to do is you want to find the mean of the frequency distribution. So if instead you don't have the original data, if you were given only this, how would you find the mean? So the first thing you have to do is find the midpoint of each class. So I'm going to write that here. So to find the midpoint, 12 to 16, midpoint, 12 plus 16 divided by 2 is 14. 17 plus 21 divided by 2 is 19. 22 plus 26 divided by 2 is 24. 27 plus 31 divided by 2 is 29. And 32 plus 36 divided by 2 is 34. So what you do when you're given a frequency distribution, instead of your original data, you assume that all the data sets, or all the data values are the midpoint. So you would assume you have 8 14s, you have 12 19s, you have 6 24s, 2 29s, and 1 34 is what we're assuming. So your calculator will do this without you having to type in 14 8 times and 19 12 times or whatever. So I'm going to go over to my list 2, and I'm going to type in my midpoints. So I've got 14, 19, 24, 29, and 34. Okay, and then I'm going to type in list 3, and you could clear out list 1 and use it if you want to, but I'm just going to use 2 and 3 since I've already got 1 with the original values. I'm going to do list 3, I'm going to do my frequencies. So 8, 12, 6, 2, and 1. Oops. Okay, so there's my 2 lists. Now, so what I'm going to do is I'm going to do second mode. I'm going to try to do second mode. And click on the right thing. Second mode. And clear this. So to do the mean of a frequency distribution, I still go to stat, I still go to calc, I still choose one of our stats, so I still choose the first one. But now what I do is instead of using only one list, like I did in the last one, I want to use 2 lists. I want it to use L2, so I hit second 2, and then comma, L3, so I hit second 3. And there are your numbers. Now, it should be close to what you had originally, but it won't be exact, because remember, originally we had the original data numbers. Now we're assuming they're all the midpoints. So my mean, my X bar, is 19.86. So I'm going to write that down. X bar is 19.86. And originally my X bar was 19.69. So it's still close, but it's not exactly the same. Okay? The mode, if I want to do the mode of a frequency distribution, which one occurs the most? This one, the second class, 17 to 21, occurs the most. But if it says find the mode, then I'm assuming that all those numbers are the midpoint. So my mode in this case would be 19, because I assume all 12 of these are 19. If it says find the modal class, then I write the class. So the class would be 17 to 21. And we know for a fact it's 17, but we don't know, based off of frequency distribution, you can't get your original data values, so you assume they're the midpoint. So off the frequency distribution, the mode would be 19, the modal class is 17 to 21. Find the standard deviation of the frequency distribution and the variance. So again, the calculator already gave me my standard deviation. It gives me SX or sigma X. And so I'm doing SX because I've got a sample. So I'm going to write S equals, and in this case it's 5.19. So again, it's not exactly what we had before. Before we had 5.3, but it's still close. And then S squared, if I do that squared, 5.19, or 19. I'm going to do the whole decimal, 187375733 squared, and it should be 26.91. 5.187. Did I type that right? 737. Okay, so 26.91. And if I just did 5.19 squared, just for curiosity's sake, it would be 26.93. So it would be close, but not exact. So you'd be off a couple decimals if you use the rounded value. Okay, so that's how you do the mean and the standard deviation, or any stats really, on the calculator for a frequency distribution. So you have to use the two lists. So it's still stat and calc. You just put your midpoints in one list, your frequencies in the other list, and then you do stat, calc, one var stats, and then do whatever list you have for the midpoints, comma, whatever list you have for the frequencies. Now, you can do this on Desmos, but I've never figured out how to do it exactly like on the calculator. I've only figured out how to do it on Desmos doing the formula. So if you want to know how to do it on Desmos, then you can watch this part. If you don't want to know, then you can fast forward or skip. I'm just going to mention the homework here in just 1 second. So what you need is, for the mean, so for Desmos, let me write it down over here. For the Desmos, the mean formula of a frequency distribution is the sum of your frequency times x, your midpoints, divided by the sum of your frequencies. Okay, so this is the formula you want to use in Desmos, which is fine. So what we need is we need two lists. I need one for my midpoint, so I'm going to call my midpoint M is equal to bracket of 14, 19, and there might be another way to do this. If anybody knows another way to do this, please feel free to share, because I've not figured out another way to do this. Like I said, I'm still fairly new to Desmos, so I don't use it very often. And then I'm going to call F, oh, I guess I'll do capital F. Capital F for frequencies, 8, 12, oops, I forgot my bracket. 8, 12, 6, 2, and 1. Okay, so to do the mean, what I want to do is I want to do my sum of frequencies times my midpoints divided by the sum of frequencies. Now, for Desmos, you can't type in just sum, because that makes you do n equals 1 to, or n equals something to whatever number. So if you do total, that's the sum. So my total of my frequency times my midpoints, okay, divided by the total of my frequencies, and it is 19.86, which is what we got on the calculator. If I go, well, I've already taken it away. Let me go back here. Stat calc L2, comma L3. So 19.86206897, and that's the same thing. This gives me 19.86206897, this one gives me a couple extra decimals, so it gives me the same answer. So you can do it on Desmos, you just have to use the formula. So the same is true for the standard deviation and the variance. You have to use the formula. And the formula for that is actually really ugly, but I did it once and it worked. So the formula, so the standard deviation is the square root of the variance. So the formula for the variance is here. So it's the square root of n times your sum of your frequency times your midpoint squared minus the sum of your frequency times your midpoints, and then square that sum, divided by n times n minus 1. Okay, so this is like really ugly to type in, but you can do it. So n is, oh, I forgot what n is. Because this is the sum of your frequency. I think n is 29. Let me try with 29, make sure. Because I think n is this, how many numbers you have here. So I've got 29, and then this will be 29 times 28. Because that's usually what n is. You're calling the frequency one thing, and then n is how many you have. So n's 29. Okay, so what we're going to do is we're going to type in, so you want to do the square root, I think it's that, okay, square root of n, which I'm pretty sure is 29. 29 times your total. Again, you can't use sum, that's the summation, like 1 to some number or whatever. Your total of your frequency times your m, and the m's are squared. And I'm going to close that whoops, I didn't have 0. Close that parenthesis, and then I'm going to do minus a parenthesis, and I'm going to do total, and I'm going to do my frequency times my m, so my f m, and then I square that whole thing, squared. And I always feel better if I put parentheses around this so that it does that whole total. So let me add those in. It's the total of f times m, okay? So the 29 is my n times my total of my frequency times my midpoint squared minus the total of my frequency times my midpoints, and then that whole thing squared. And then I'm going to divide that. Oops. Oh, shoot. I need a whole parenthesis here and a parenthesis here so that all of it gets divided by n times n minus 1. So divided by 29 times 28. And hit enter. And it gives me 5.187 dot 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 5.187. So you see the calculator gives me the same thing, but Desmos it was a lot more difficult to type in. So like I said, if anybody knows how else to do that using the to list on Desmos, I'm more than happy to listen to how to do that. I just haven't figured that out. I've always had to use the formula. But it will work if you use Desmos. You just have to be careful. And so to do, this is the standard deviation because it has the square root. If I want just the variance, what I could do is, can I copy and paste that without the square root? And it gives me the 26.91. So there's my variance. Okay, so that is how you do everything on the calculator or on Desmos, whichever one you want to use. Or some people, I've had some people, I've used Desmos the first time in the last class I taught, last time I taught statistics. That's why I'm not like super good at it. And I had some people use them both just because they wanted to know both, and then they checked their answers. So if you want to use both, that's totally fine too. Okay, if you have any questions on any of that, please send me a message. And I know these videos get a little bit long doing all this, but anyway, so your homework for this week is you're going to use the all-time North American domestic top 20 movies, and it says as of 1/21/21 because I pulled the data then. It's not changed. right now. Today's the 7th. And so when you're doing this, it says to label using appropriate symbols. So if it's a sampler population, it says the word all, which indicates population. So even if it changed as of this date, it would still be a population because that would be all time, all of them. That's all top 20. Okay, so you should be using mu and sigma and look at sigma on the calculator. So there's your hint for the homework. So you're going to use the length of your movies in minutes to do these. So you're going to do the same thing we did. Basically, you can follow along on the examples, find all of your statistics or everything here that it asks you to find out if it has an outlier. And then in this one, I didn't make you create the frequency distribution. I went ahead and did it for you, but then you go through and do it again, just like we just finished on that last problem. And then use your range rule of thumb to do the unusual, which we did on number 4, and then your box plot, which was number 5 for us. So it should be pretty straightforward. You're going to do just what we just finished on the examples. So like I said, if you have any questions, please message me.